Yeah. Hi. Um, so today we'll continue the verification that we're doing with respect to embedding. It's taking a long time, I understand, but and it is going slow. I should actually speed up. So I'll try to make it as fast as possible. But I really want to understand it in detail before more. So yesterday we looked at this code. These are the text. He has taken some text, training text, and in the training text there he's actually removing certain stop words um, to start off. Um, my text is second of Windows S3. That means you should take it as a slider length of three word length, and then it will keep moving down. So you keep a slider, you pick up the third word, move the slider to the third word, and pick up the bottom two words. So the two words above and below will what be picked up if your window size is 3. If your window size is 4, then three words you're starting and three words after them. Excuse me for having my breakfast in parallel. I really feel hungry for some reason today. So for some reason it is not good. Okay. So and besides that, we also added the negative sampling technique. So instead of saying that these are the words that are there in the context, we also say these are the words which are not there in the context. How did he pick negative samples is from the whole text. Randomly he's picking 3 samples, but making sure those 3 samples are not part of either the center word or the context words. When I say center word and context word, if you look at this flow, window size 3, 1, 2, 3, fundamentals is the center word. Today learning will be context words. Besides fundamentals, data science. So these 4 words will be context words, fundamentals will be center word. And then you move to data, that will become center word. Learning fundamentals will be context words. Science and statistics will be context word. That's how the window keeps moving with respect to center word and context words. Now, native words are random words within the sample. For example, fundamentals. Today, learning data science are context words as we have seen. And for each word that we pick up in context, there he is picking up 3 words in negative sampling, which are not in context kind of stuff. So and today is being picked up, he picked up better artificial expert, which is not part of the context. And learning is picked up, he picked up really hot, really, which is not part of the context. He should have avoided the repetition of words here so that it will be much more efficient, because predicting same negative word twice doesn't add much value. So till the negative sampling is How do I see this chat and well? Okay, I should get notification. Sir, what exactly you're learning? Can you give me a quick summary? Okay. Um, so what we're looking at is embedding. Till now, whatever videos we have seen, we looked at all different steps. Um, as you know, neural networks are RNN, are transformers and coders, whatever. Doesn't understand words directly. We should embed them. So ideal embedding is simply one hot encoding where you have a list of words and you keep one at the corresponding word kind of stuff, right? That's how you do encoding. But that doesn't really help in the NLP models. So they go with the embedding. Also, I'm trying to understand how the embedding works. So one of the different embedding techniques like word to vec, fast text, um, Elmo, and stuff. So different embedding brings different words. Embedding not only brings not only helps in representing a word with a number, it also actually brings in a context and features. Like in CNN, when there is an image, for each part of the image, we extract certain features and then understand what it is. Similarly, um, for for even words, they are extracting features. Which is very interesting. So, how are they extracting features? We don't know. Similar to images, right? We don't know how they are understanding that a image within a section. They understand that it is actually here. It is eyes and stuff, right? So, the neural network, by looking at multiple images, they draw patterns and understand things. So similarly here, they draw patterns and understand word meaning, but majority of the meaning is being given by embedding. So that's the reason embeddings is very important. I'm trying to dig deep into embeddings at WordWork to see how it is actually extracting those features out of the words and representing in a numeric format. It's a vector, like each word is a set of words, set of numbers. Um, the beautiful part of it we'll see is the words get closure. How can we say that it's extracting a meaningful context is we know English words, and if you look at a group of words, they are actually close to each other from the vector perspective. That itself says that it is really understanding the words, not randomly giving you some numbers. So how is that happening is my point. In exam, for somebody who's listening, it may or may not be necessary for you guys, but it's actually my personal interest. I'm digging deep into it. Okay. So this piece we understood the code piece part of it. So we just preparing a data. In this data, actually, in turn, he has this also we have understood yesterday, where the context word and center word, if there are any intersection between these two words with respect to repetition and stuff, those words are being removed from the list. But in this context, there are not many words which are repeated removed. If you see there around 983 being 984, out of which 983 are being considered. And just one row is removed, considering it as a duplicate. That's all. Nothing more. Means this code is helping removing duplicates. That's all. Now moving on. Yeah, good. He's looking at. No, this is my code. I was just looking at the unique words in this output. So the final data frame that he prepared comes out like this, where we have the center word and the context word, and the label shows whether it's the right context or not. For example, fundamentals and learning, it says label is 1. If you look at fundamentals here, the learning is here. So For fundamentals, today learning data science will have one. Mm, here. So yeah, I mean, let's just quickly look at it. Insert, of df of. I'm just trying to verify what is. I'm cross verifying that the labels are given properly. So for fundamentals, I'm verifying on what is all the words that are captured. It should be 3 into 4, 12 words, and 4 should have ones. Oh, okay. There is one more part to that story, right? So it could there could be a repetition of fundamentals within the text, so there could be more as well possibility. So fundamentals had 15 words. I don't know, man. I don't understand everything, but okay, that's fine. So there are 15 words he is picking up, in which learning is one, data one, science one. Learning, data, science. What happened to today? Interesting that they removed today. Mm, mhm. Is it because today itself is not there? Context underscore word is what today? Totally removed. It's totally removed. That's interesting. Why is today removed? This one only. Sigmoid v comma scale sigmoid function 1 by 1 plus exponent of minus square into v. Okay. This is a complex thing to understand. Update embedding. Data frame, main embeddings, context embeddings, learning rate, and yeah. You get differences between main embeddings. First of all, he needs to explain what is main embeddings and non services. We'll come to the method again. Normalized data plot words will come when he calls it will come. So now he says embedding size is 5. So when he says embedding size 5, that means he's saying he will use 5 numbers to represent each word. That's what he means. Embedding size 5. It's mostly like a vector of size 5. That's what he'll use. So coming to word to vec. Okay. So this will be 5. Length of the words is 5. No, length of the words is some 300 or something. Print. Okay. Length of the words is some number, and embedding size is 5. So row underscore norms. We should print all this and see. Okay. So now first let's debug this. And p slash square root of embedding square plus square sum shape minus 1. Same thing is doing with context embedding also. Index words. So initially by default he's giving a it's giving some value. So let's just look at the initial values. So these main embeddings initially are like this. Then row normalization, you're normalizing those values. You're dividing them with this normal value. It's just like normalization where you're normalizing the values. That's all. For each word, file size. This is the main embedding. This is the context embedding. This is something interesting to understand, right? So main embedding and context embedding are being picked up as two different values. Why? Same word has one actor as main embedding, another vector as context embedding. This is a question to be clarified. And post that, it's just running a loop for 25 times, in which this main embedding and context embedding are being updated. Okay. So if we run this, this is another thing. Every time you run it, the embeddings are changing. So when you train a model, makes sense because we didn't run the other. So We'll go to update embedding, data frame, main embedding, context embedding. 0.1 something is passing. I don't know. Let's look at the method. Update embedding, data frame, main embedding, context embedding, learning rate 0.1, debug equal to false. Which is good. Is where is it? Where is it? No, here. Um, Here he is sending learning rate, comma, or debug data and science is what he's passing. If you don't pass anything, it will be false. Otherwise, debug is equal to those two words. Okay. Okay. So context embedding. So these two we are he's taken values of both of them in one place, and then he's doing a difference of those both values. This okay done. Get similarity scores and errors between main embedding and only context embedding. Dot product. Dot product of these two. Sigmoid of dot product. This is error. Okay. Got it. Calculate updates. Updates is differences into errors into learning rate. To learning rate. Okay. That is good updates. Again, they are so it's a loop in which this is looking at the error in between similarity scores and errors. Scores is by sigmoid. So error is sigmoid values to actual sigmoid values gives certain okay. Let's look at simple and see. Hmm? I gave space there. That's the message. Again. Oh, he's using debug as a variable here, and we are using it as a method. Okay. Okay. Now let's see. This is the embeddings and next, right? So hey, I defined sigma is on top, is it? So if you go here, let's look at the debug. First is I had main embedding, context embedding, and then dot product. Okay, sigma of dot product. This is, I think, dot product. I think dot product and what about compound? So dot product output. So these two are the uh, let's see. What is the difference in between this? Let's look at it again. These are just the dot values. Mm, only center word he is taking, only context word he is taking. This is only center words, only context words. But if you look at this is center word 300 30 44 04 26 09 83. But here are different, and they are being repeated also. Did we do anything after printing these? I should look at it more into it. Okay. Okay, this is dot product output. These are scores. This course is nothing but sigmoid applied right on them, which says which is a one and which is not a one. Yeah. These are errors. Okay. So if I scroll down all the way down, let's use the bar and do it. 25 times, so it will be so the errors got minimized, but they're not that low. Minus 0.3, 0.2, 0.6, positive 0.6. These are all are high only. Still, they're not that close. Errors. So these are all the errors. They're trying to reduce the errors overall. What is this and what is this? I should look at the graph, plot graph. So now for W1 in words and unit in words. Each word and corresponding other word, he is trying to show us what is the main underscore embeddings. Mhm. Word 1 and word 2. Okay. So main embeddings is the final embeddings of each of them. Cosine is to look at the correlation between both of them, how much close they are. Like data and talk is 0.5, they're far, but whereas the remaining are very close. That's what it's trying to say. Instead of data, let's say we look at fundamentals. As we have printed fundamentals, oh, I need to go long way. And data and science system. Today, learning by fundamentals and learning. Today, they have removed that. I've seen learning or listening to see. So closest to fundamentals is talk, become, became, and let's say science. The listening, thanks, long, hot, good talk. So this is five dimension vector. We're using PCA. We're shrinking it down to two dimension vector. Plot figure size. Figure size is equal to 5 by 5. Numbering 0 1. But in column 0 less than minus 0.25. I don't know why this guy did this. This is like studying is coming here. I can't find data in this. Data, statistics, and science. Anyways, we need to run this. So mhm. I have not installed a scalar, so this will not work. That's okay. So what we need to look at is main embeddings. Let's print main embeddings and see. This is the final embeddings for each of the words. If I go kernel, restart and run all, so it'll take some time. I should have copy pasted that values. We need to see whether the embeddings will be same or they will be different. They will be different. Obviously, they will be different as for math. No? See, 0.531649. Okay, let's copy this. And make this okay, this ran. See, now it is different. This is the most challenging thing. If the embeddings change every time, how does the model understand that this is and the words are similar and what it is being trained and what it is get now. Okay. Sarvo. Typing, I can hear you crystal clear. Didn't watch the full live stream, but yes, I think you should add description. So also. Thanks for joining. Oh, okay, I can end the stream and reply, right?